about 1 minute after the hour, so we're going to get started. Hi, everybody. My name is Bob O'Sullivan. I'm the Associate Publisher of Test Prep at McGraw-Hill. And the team and I are really pleased to welcome you to our 5 Steps to a 5 webinar for AP Computer Science Principles. If you can punch to that first slide for me, Julie, please. Just before I hand it over to the host, Julie Sway, I'm going to go through just a couple of housekeeping issues. First of all, for those of you educators out there, just to let you know, we invited both teachers and students to this session. It is primarily a student-focused review. So if you want to go share this with other students, that's where we're coming from. I thought it was important to mention that up front. If you have any questions throughout the session, we urge you to use the Q&A feature at the bottom. Please submit your questions right in there in the Q&A. If you get in there and someone else has already asked that question, just hit the thumbs up. That way we know it's an important one that will sort of jump to the top. We mentioned here that the chat feature will be live, but we're not going to be monitoring. The truth is we actually have kind of been monitoring that, the other ones that we've done, and I think this is working pretty well. So if you have something important that you need to share, that's another option too. But if you do have questions about the content, please feel free to ask in the Q&A feature. Just a quick note that you won't be able to see one another. Any other participants on the call, you won't be able to see or hear one another. You should be able to see myself and Julie. An important note for the teachers, I know this is a concern that people have. There's absolutely no student data being collected for this session. No student email addresses, no student names or photos. So if that's a concern, we want to address that up front. We're not having any of that. Our presentation will be interactive. It's much more fun when everybody gets involved. Please do participate as we go through. There'll be some multiple choice questions. A polling feature will pop up. Please feel free to participate in that. It makes it more interactive and a good time for everybody. And the final note is just that the session is being recorded. At the end of this 90 minutes or so, you will be able to visit the URL, the bit.ly at the bottom. If you want to take a few seconds and take a quick photo of that with your phone, that's where the recording is going to live. So anyone that wants to access it as of this time tomorrow, share it with your fellow educators or your students or anyone out there. The recording will be available. With that, Julie, next slide. The quick agenda is we're going to hand this over to Julie and learn a little bit about her. She's going to tell you a little bit about her reader notes. As a College Board reader, she has some pretty valuable advice to share with us as we approach test day. She's going to talk about essential topics that we need to review, the most important stuff to review in the next 6 weeks or so. We're going to review and solve some questions that are in our 5 steps guide. And then at the end, I'm going to do like a couple, maybe 5 minutes or so, just to show you the digital course that we have that everybody on this call will now have access to, and we'll fill it. We'll finish things up with a Q&A. Before we get started, I don't know if there's anyone from on the line that's from either North Carolina or Kansas. But Julie has some really strong feelings about tonight's championship basketball game. I'm not going to tell you which team she's rooting for, but she's a big fan, and I don't want to alienate anyone out there, so I'm going to leave it at that. So Julie, with that, I'm going to pass it over to you.
All right, very good. Thank you, Bob. And yes, we'll see if you can guess, but all we know for sure is that Roy Williams will be happy with whatever team wins since he coached at both places. So if you get a close-up, you might be able to make it out from my earrings, but we'll go from there.
Are those actually, are they branded earrings for the institution you're rooting for?
They are, and they are basketballs in the middle. So let's hope that, you know, the best team wins.
Love that.
We'll leave it at that. So just to introduce myself a little bit more, I am teaching at a 3K through 12 independent school, but I do teach in the high school. I have served as an AP reader for this course since its first year. I've been teaching this course since it started, and actually the year before, even though it wasn't an official AP class, we had the curriculum and we were going through it just as a regular introductory computer class just to get a little familiar with the curriculum. So I'm very familiar with it. Before becoming a teacher, I've worked for both Coca-Cola in Atlanta and Vienna, Austria, sehr gut. And then for Southwest Airlines, both places in software development. So I have the industry side as well as the education side. And as you all know, this course covers a lot of topics. It goes wide, but not as deep. So there's a lot of material to learn. And let's just get started with our review. So we are going to start, as Bob said, with the chief reader notes. And these are provided by the individual who is in charge of the AP reading for this course. It changes, whoever it is usually does like a 3 or 4 year commitment. And so starting last year, it was Tom Cortina, and he is a professor at Carnegie Mellon University. So these are his notes from last year. And they're very helpful. They give these to the teachers so that we can improve our teaching for areas that our students and students across the board may have missed. So as hopefully you all know, you have 3 things that you have to submit to the College Board. So the WR, when you log into the College Board digital portfolio to submit your work, you'll see WR, and that's the category for your written response to the prompts. You have to submit a video showing all or part of your code working. And as one of my students learned, if your video is too large and their requirement is 30 meg, then it won't even load. So you'll have to go back and compress it and then try to reload it. And it's not a problem from there. And then you also have to provide your program code in a PDF format. All right. And my main request there as a reader is to make sure it's legible. It's okay if it's somewhat small, as long as if we enlarge it, then it doesn't pixelate. It's still viewable, okay? But those are the 3 things you have to submit, okay? So let's just go through the prompts there and see what the chief reader had to say. So last year was the first year that we had a revised curriculum. So this program started, this AP course started back in 2016, and so it went on for a few years, and they said, okay, now that it's been out, let's get feedback and improve it. So last year was the first year we had the revised curriculum, and it is the same again this year. So we have some good notes, good comments from the chief reader. So the first section that you have to write about is talking about the program purpose and function. So what we noticed last year was that a lot of students confused purpose with function, and you've got to make sure you have those correct to earn the point. So there's only 6 points total that you earn for these, and they have multiple sections. So you got to get all the sections correct to be able to earn the point. So just remember that the purpose of your program is the what, okay? It entertains, it teaches, it influences, it quizzes, it helps you design, that kind of thing. And then when you talk about the functionality, you're talking at a high level, but you're talking about how it does it. So, it creates a multiplayer game, you play against the computer, it displays facts, then it displays quizzes, things like that. And if you have those backwards, you still have time to fix those, okay? If you haven't submitted final to the digital portfolio site, then you can still change yours and upload a new version. And the readers only see the most recent version. Okay, so then the other thing you also have to write about is the input and output demonstrated in the video, okay? You don't have to show your entire program working. If you only have part of it working, just show that part, but it does have to be working video, okay? You can't just show screenshots or anything like that, okay? But you have to show input being provided, and then of course your program is doing something with it. And then as you see in the chart over on the right-hand side, you get output. And that's what you have to make sure you wrote about. You can't write about something else, like a different feature that you're not showing. Okay? All right. So let's move on to the second section here, section 3B. So we're talking about data abstraction and managing complexity. So we're talking about lists here, okay? There are other ways to show data abstraction, but this program or this course looks at lists. So again, as I mentioned earlier with the other screenshots for your code, you have to provide 2 screenshots here. Please make sure that they are easily viewable, okay? People with older eyes than yours need to be able to see them, okay? All right, you have to show how elements are stored in the list. Now, if your list starts out fully loaded with either questions or numbers or anything you might have, then show that where it's defined and those are set up in there. But if your list starts out as empty, then make sure you get the screen clipping where you're either using append or insert to load elements into your list. That's what the readers need to see, is where the data is loaded. Okay, and then also show how the list is used in your program. Okay, so don't just show where it's an empty list and nothing has been added to it yet, or don't show where it's, don't pick a snippet where you don't really see the code, anything being added to the list. All right, so step number 3 should be pretty easy. You're just going to give the name of the list, but just one name. Only one, okay? Many times last year, students would give me multiple lists to look at. And when that happens, the readers are only allowed to look at the first one. And that might not be your best representation of a list and its use in your program, okay? So just give one list, make sure it's the right one, make sure it's the one you use well in your program. And then in the next step, you're saying, what does the data in the list represent? Well, it could represent questions. It could represent teams. It could represent basketball statistics, things like that, okay? So just briefly describe what it represents. And then number 5, this is the one where a lot of students just kind of lost the point there, okay? Some students would do a good job describing how a list manages complexity in general, but that's not going to be enough to earn the point. You have to describe how it manages complexity in your particular program. Okay, so you can say, yes, a list manages complexity because I can store many values in there and then use them to pull them at random or to process the whole list, but that won't do it. Then you have to go on and say, because in my program, etc. Okay, so make sure you add that extra piece and feel free to use that verbiage. In my program, the list manages complexity by, okay? And don't just say that, well, my program couldn't run without a list. Most cases, 99% of the cases out there, a program could run without a list. It'd be a lot more complicated and a lot more variables and processing to worry about, but it could work. So don't just say that it couldn't run without a list. That too won't earn the point for you.
Julie, real quick, Karen Purcell has asked, the screenshots must be an actual screenshot and not the PDF of the code, correct?
Correct. You will be like copying and pasting that screenshot into the digital portfolio site, and they have a little spot there for you. You could take a screenshot of the PDF if you already have it in one, and that will be fine too.
Thanks, Julie.
Okay, moving on to question 3C. So now we're talking about procedural abstraction. So these are our functions, okay, or procedures, depending on the language you're using. They use those terms interchangeably. Okay, you do have to make sure this is a procedure you developed. We would often see a student write about an on event that some programming languages such as JavaScript have. That is not considered a student developed procedure. Now, you might have an on event inside your procedure, but it still has to be something that you define and have some kind of processing in there. So once again, screenshots have to have a screenshot of your procedure and then a separate screenshot of a call to your procedure in the program. It's just a quick review. Remember, your procedure or function will not run until it's called in your program. So we have had cases where students would define a lovely procedure, but then not ever use it in their program. Because if they miss the call, we'll go back and look at your program code. And that's why that PDF is so important, and make sure it's legible. If we don't see it right there in that section, we'll go look and see. So you want to make sure it's legible and you want to make sure you use it, okay? And then you're going to describe what the procedure does and how it contributes to the program's functionality, all right? So these are some of the chief readers' notes here in particular. Students who describe their procedure at a higher level did a better job earning the point, basically, and connecting it to that functionality of your overall program. So don't say, oh, in the first line, I set a counter to be 0. And then in the next line, I check an if statement. Okay. You can just say something more like, oh, I prompt the user for values, and then I load those into a list. And then I process through the list. So you're talking more at a higher level. Okay. And that kind of, it's just an observation. The other is not necessarily wrong, but most students did a better job earning the point talking at a higher level about it. Do make sure you have at least one parameter in your procedure, okay? And make sure that you are using that parameter later on in your code. We definitely had examples where either there were no parameters or the parameter was there, but never used. Just like with lists, if you have multiple procedures included, then only the first one is considered for us to look at for your score, okay? Now, if that procedure calls other procedures, yes, we can consider those other procedures because those all work together to form the overall algorithm. But if you have several standalone procedures, we're only going to look at the first one. And it's sad if that first one doesn't have a parameter and a later one does, but that's how it works, okay? All right, and then in the last step there, you've got to make sure you describe how the procedure works in enough detail that someone else, like the reader, could recreate it. This is where you are going to go in a little bit more detail so that people could say, oh, okay, I need to have a loop here. I'm going to process the whole list. I'm going to compare each element in an if statement to see if it's greater than 0 or whatever might be appropriate for yours. Okay. And then the last section, 3D, we're still on our procedural abstraction, okay? So this is where they really break it down pretty granularly. You're going to create basically 2 hypothetical calls to your procedure, all right? Make sure you are referring to the same one you wrote about in the last section, all right? And each call needs to result in different code being executed inside that procedure, okay? So first, you're just going to give the 2 calls, okay, with the arguments, because you know you're going to have at least one parameter. Then the step 2 says, well, what condition are you testing? All right. An if statement is a great way to do that, because if it's true, you execute one set of code, and if it's false, you can execute a separate set of code. And so you can have arguments that will hit that condition in both cases, but result in a true or a false result. And that's the last step of what you do is say, oh, well, as a result of that condition being true, I print this out, or I process that, or I display this new level, etc. So those are the steps that you have to write about. And again, it's not too late. You can go back and modify any of yours if you haven't already submitted final. All right, one of the things talking about that PDF of your code, some programming languages, many of the block-based ones, don't easily print into a PDF format. So a wonderful computer science teacher, Baker Frank, created a module below that will easily create that PDF for you. It's not required by any stretch, but it's very helpful if you need it. My students are using Python, so they are just copying and pasting the code that they need, but this does work very well with block-based code. So just know that that is freely available for everyone. And okay, so your create performance task, all those steps are due May 2nd. All right, little caveat about the time here. The College Board posts on their site that it is due at 11:59 Eastern Time. They specifically say Eastern Time. I have seen each year in some of the teacher forums where people have posted, oh, it didn't close for us at 11:59. And these are people who are in other time zones like the West Coast. Now, don't count on that, okay? Just because it's happened before doesn't mean it will happen again. It's great if it does and you need that time, but don't do that to yourself and don't do that to your teacher. Just have it done earlier and then you can just relax because 30% of your score is already done. You can't even touch it again once you hit that submit final. It's done and you can relax about that and then focus on the multiple choice part, okay? All right, so if there are any questions, put them in the Q&A section right now while you're thinking about it. And Bob will let me know if there's some that make sense to go ahead and answer now. And otherwise, if you see at the bottom of your Zoom panel, the icons, click the one that best represents how you are feeling about your Create project. Hopefully it's a thumbs up, or you're giving yourself a pat on the back or a hand there celebrating.
Julie, there was one quick question that came in from Jan. Are line numbers required on code?
They are not.
No.
They are not required.
Thank you.
It's helpful if you've got them, but it is not required.
Got it. Thank you.
All right. All right, so let's move on and take a look at some of the essential topics. These are ones that I see with my students, and again, in teacher forums and training sessions and just conversations that we have. These are the things that pop up regularly among all of us that our students, usually need a little more time to process or struggle with just a little bit. So we're going to briefly review procedures, parameters, and the return statement. And those are all related to procedures. And then we'll also go look at lists in a little more detail, because as you just saw, you have to write about procedures and lists in your written response. I love this diagram here on this one because it shows the whole black box approach for a procedure. That's what makes it abstract. All the details are abstracted away, and all you have to worry about is the input, what type of input does it need, and then what type of output to expect. You don't have to know any of the details about how it works. This applies to whether you're using a built-in function, one you get from an API, and even one that you write. Once you've written it and tested it well, you don't have to worry about it either, and you can use it in this program or others. Remember that procedures can be called as many times as you need in your code. And as I mentioned earlier, it's just going to sit there until you call it. It's going to be like, okay, I'm right here, coach, put me in the game, but it won't get put in the game until you actually call its name. All right, your code is much shorter, much more readable using functions because you're not duplicating and copying the same code multiple times. And then the best thing is that you only have to update it or fix it in one place instead of all these places you may have copied it. And our code is much more flexible by letting us use parameters. I can do it. I can use this with any type of parameter that meets the requirements. Like if you're expecting a string, you better insert a string. If you're expecting a number, you need to use a number. All right, so that's the whole procedural abstraction idea. So here's the format that the College Board uses for procedures. Okay, so this is the format that you would see on the multiple choice questions. And here's the parameters inside of our procedure. And notice when you call it, here's its name, procedure name. It's got to match that exactly. Capital letter there, lowercase for everything else. And then the first argument gets matched to the first parameter. The second argument gets matched to the second one. Okay, they just get mapped directly. The parameters just sit there with no value until it's called and that value is passed through the arguments. And then it's used internally. Looking at scope of parameters, okay, you got to remember that parameters are local to the procedure. And I kind of put a little house around it here to kind of represent that. Poor little parameters do not get to leave the house, okay? So what's actually happening is when the procedure ends, the programming languages will then, what the term is actually garbage collect. So it will garbage collect any of these values that are no longer needed outside of the procedure, and it frees up the memory so it can be used for other values. That's why it's confusing when you see, oh, undefined value, and you're like, no, it's not. I see it right here in my program. What's going on? It's because its scope is just within that procedure. Okay, so here again is an example, pet care. We have a capital C, everything else is lowercase, and it has one parameter here, so we have to send it one argument. And notice I could send a variable called arg1, or I could send a string of any kind. It doesn't always have to be in a variable. It doesn't always have to be in a string or a number if that's what it's looking for. But just remember that parameters, their scope is only within that procedure. But here's where our return statement comes in handy. Sometimes we do want to send values back from our procedure. So the return statement immediately exits a procedure. So you could have it like if you're dividing and you run into a case where there's a 0 and you're going to try to divide by 0, check for that and then exit the function and send back an error message instead of having your program abort right then and there with an error. It sends control back to the calling location. Okay, so remember when you call a function, your program pauses, goes and finds the code with that name, runs it, and then returns control back to that calling location. You can return any type of value, a number, a string, a Boolean. You can even have an expression there, and it will evaluate that expression before it sends it back. So it'll evaluate it down to a single answer or a single value, and then send that back. This is the part students miss a lot. If you send back a value, you have to have a way to capture it. Otherwise, it's kind of lost in cyberspace. All right, so you need to store it in a variable for later use. You can have it in a display statement or a print statement and just print that outcome. But if you want to use it for later processing of any kind, you got to store it in a variable. All right, moving on to lists. Quickly review. Lists have elements, and those are the actual values in the list. So in this case, we have dog, cat, bird, and turtle. Those are my elements. We can get to a location or a list through the index. All right, so they have an indice that represents its location in the list. And there are methods that you're responsible for knowing for the to use with lists. And we'll go over those, but that's the append, the insert, the remove, and the link. And then lists were made to use with the for each loop. Makes it very simple. You never have to worry about starting or stopping an infinite loop or anything like that. The for each loop is going to take care of that for you. All right, so let's start with length. Length comes in very handy, okay? So all you have to do is give the list name inside the parentheses here. So what list do you want to know the length of? Or what string do you want to know the length of? And it just returns the value as an integer. So in this particular example here with our list pets, length is 4. Now, it's also handy that that fourth position, the length of it, is also the last index because you can use that to your advantage, especially if you have a very long list. You don't have to count elements yourself. Use the length method to figure it out for you. All right, append. Again, the format is to give the list name and then what value do you want to append? And it always puts it at the end of the list. So here, for our example, we have append to the list pets, and we want to append the value fish. And so this is what our list would look like internally with its index. The length of our list has expanded by 1. And here's what our actual list would look like. All right, insert, very similar to append, but it doesn't put it at the end of the list unless you tell it to. And then why would you use insert? You might as well use append. So in this case, you can insert somewhere inside your list. So you give it the list name. The next value you have to give it is the index position where you want to insert, and then the actual value. So if I want to insert hamster at position 3, notice what happens here is that bird does not get overwritten with hamster. Okay, so what the programming language does for us is that it moves anything to the right of that value where we want to insert over 1 position to the right, and then it inserts hamster. So notice we haven't lost bird. It just moves over to position 4, turtle moves over to position 5, and fish over to position 6. So again, the length of our list has changed. It's increased by 1, but that's nice to know that things don't get overwritten. You don't have to take care of that yourself. And it's similar with remove, okay? It's the list name, it's whatever is stored at that index position. So I'm not saying remove bird, I'm saying remove whatever's at index 4, and it just happens to be bird here. The length of your list changes down by 1 in this case. And again, we don't end up with a hole in the middle of our list. All these values to the right of it are moved down in index position. Okay. And then the list and the for each loop. Again, they were made to work with each other. It's really elegant and really efficient. So here's the format. The words in all caps are the required words. And then we get to define the item. That's our iteration variable. And this is the part that students have usually take a little bit longer to process, is that for each iteration or each pass through our list, this item is going to take on the value of each element one at a time. So for the first pass through our list, item is going to be the value dog. And whatever you have here to process the element, it's going to just compare dog to everything. Then it comes back up to the top and says, okay, I'm not done yet. What's our next item? Cat. The variable item now has the value cat, and all the processing is applied to cat. And then it continues on the next loop, next pass through the loop. It says, oh, not done yet. Let me take on the value hamster and processes that. And then when it does the same for turtle. And when it gets to the end with fish, it says, okay, I'm done now. Close the loop, go on to the next line of code at the end of it, or stop the program if that was the last one. Just be really cognizant of the fact that item takes on a single value in the list each pass, not every value in the list. I think that's the part that catches students the most.
Julie, real quick time check. We're about 4:32, so we're a little over 1/3 of the way there, just letting you know.
Okay, thank you. All right, and then once again, if you have questions, put them in this section right now, and if we can answer them now, we will. And otherwise, let me know how you're feeling about procedures, parameters, and lists, along with the return statement. Hopefully it will just be a good review. All right, so let's get in and actually do a few practice questions. So if you've had this class for a year and you've been moving on to some of the areas, it might be good to review some of these algorithms and programming questions in particular. So we're going to pop up a poll. And so you'll see the poll like that, okay? And you'll click on the response that you want to give for your answer. And then once we're going to give a minute for each question, which is less time than you'll actually have on the exam. And then we'll go over the correct answer, okay? So here we go.
Quick note on the poll for those of you at home, if you can click and drag that over to the side, and so it doesn't block the question, and it should stick for the rest, for all the questions to come.
All right, very good. All right, here is the first question. All right, and that is approximately a minute. So if we can see any results. All right, there we go. And here is the correct answer. It is D, index out of range. So let's take a look at that one. So here's our string. And what I've done is I created a table down here, and I put each element of our string, each character, with its index position. And if we're looking for fact, which is our variable name, at index position 19, because notice the square braces there, then we don't have an index position 19. And so it wouldn't by default pick up the last element. So it's not our exclamation mark. It wouldn't pick up the quotation marks because that just show the programming language it's a string. And it does not wrap around to go back to the beginning and get our capital C. We get an error, index out of range. All right, next question. All right, that's about a minute. Let's see how we're doing. All right, so pretty spread evenly across the board here. So let's definitely talk about this one. So this is one of those questions where I highly recommend that you trace your code and write in the booklet. Okay, you can't take scratch paper in, but you are allowed to write in the booklet. And so what I did was I created over here, so I kind of put a line here to separate the question. The correct answer is runtime error, but if you look at this, you might not see what type of error it is. So set up a column for your variable count and give it its initial value. Set up degrees, it starts at 78. Then we enter our loop and we're going to keep going because 5 is not less than 0. And then I created a column here for AVG, for average. And I didn't calculate it out. All I really need to know was that it's the current value of degrees divided by the current value of count. And then degrees has 3 added to it. So it's now 81. Count has 1 subtracted. It's now 4. And then we go back up and we check our loop. We still keep going because 4 is not less than 0. AVG becomes 81 divided by 4. All right. Degrees becomes 84. We add 3. Count becomes 3 because we subtract 1. And then we go back and check our loop again. We're still in it. So we update our values. Okay. We're still in the loop. We're getting to 90 divided by 1 for AVG. Degrees is 90. Count is 1. All right, 1 is still less than 0. All right, so now, oh, we're down to, sorry, I was off by 1. So we're at 93. Count becomes 0, but 0 is not less than 0. So we are still in our loop here, and this is where the problem occurs. AVG now becomes 93 divided by 0. And just like in math, you can't divide by 0. So that's where our runtime error will occur. Everything runs just fine up until that point. And this is where you really have to test your programs well so you don't accidentally run into one of those conditions. So that's where that error occurs. All right, next question. All right, that's about a minute. Let's check our results. All right, yay, way to go, everybody. So once again, I put our same string, coding is awesome, all right, down with the actual index position. And so I have seen a question similar to this in some form or fashion on all the released exams. So just kind of be, to watch for it. So we're going to take fact, and notice it tells us the string, the starting position, and the length. So sometimes they might mix or change up the order of those. So just watch for the instructions up here very carefully. So we go to 14, go for a length of 4. So we do not include the exclamation mark. We concatenate with the plus sign with strings, a space, and then we concatenate starting at index position 1 and for a length of 3. So we have some cod. Good job, everybody. All right, here's the next one.
Quick note on the polling, please participate. It's more fun when everybody does it.
I know, trust yourself.
Yeah, trust yourself. No, you know what? You're not getting graded on it. No one's going to know. It's you. So feel free to guess even if you have to.
All right, and that's about a minute. And the answer is, okay, so in this one, the answer is B. And let's take a look at why. Okay, so we have if statements and then else if combinations. So we start with degrees at 75. And as you can see over on the right here, again, this is another thing you can easily put into your booklet. Okay, so degree starts at 75, the day is Sunday. Now we have and or statements. So you have to remember whenever you have an and, it's only true when both operands on either side of it are true. All right, an or is true when either or both operands, but you need at least one to be true for the whole condition to be true. So if is 75 greater than 75? No, it is not. And so since we have an and, we have false and so we already know the whole thing's going to be false, but you're going to have enough time to look at that and just confirm that, all right, our day is Sunday and it's checking to see if day is Friday. So we're comparing false and false. Now, what I really want to point out here too is occasionally I get a student who thinks that if they're both the same, it makes an and true, and that is incorrect. They both have to be true for an and statement to be true. So it is not this first condition. Let's look at the next one. So is 75 greater than 65? Why, yes, it is. So we have true for that side. And then we have an or. So we really already know our whole condition is true because we have at least one part, one operand on the or statement is true. So we have true or, and in this case, false because our day is Sunday, but it's okay. The whole thing is true and it's going to print out, wear a sweater. Okay, next question. And that's about a minute. All right, so let's take a look at this, and we have a little bit of discrepancy in our answers, and the correct answer is D. And let's break it down so we can see this, okay? Just to make everything fit, I kind of segmented off. Again, this is what I would write in my test book, okay? So we have red and green as our first display statement here. So red is true. So we have true and false. And as we just discussed with an and, both sides have to be true. So we already know we have false. And we can eliminate two answers up here. We know it's already going to be either B or D. So now let's look at the next one. We're displaying not green. So that is not false, which is true. Remember, the not just flips the condition. So not false is true. And we already know now our correct answer would be D. And we can just double check with our blue or not red and green. This is one of those cases where we have to evaluate the blue or not red first down to a single true or false to be able to compare with this side of the operand. So blue or not red is true or not true. And that's okay if they're not true because we only have to have one part be true. So we have a true and green. And then we have green is false, so true and false, and we're back to false. So that correctly prints out false, true, false. All right, moving on. And that's about a minute. And let's see our results. Okay, all right, pretty good. So our correct answer is indeed C. So let's kind of discuss that real quickly. You're going to have to kind of use a little bit of logic here, all right? And just think about when doors are open, we send in an alert. So if we have a counter keeping track of that, then when it's open, it's 1. When it's closed, it's 2. Open again, 3. Close 4. Open 5. Close 6. So the pattern you should see is that whenever it's open, the number is odd. And then whenever it's closed, it's even. So then we just have to check our options here to see which one of those correctly alerts for that. So if you remember your modulus math, okay, any number divided by 2 with a remainder of 0 is even. So we already just said that, hey, it's going to be odd when the door is left open. So this is not the correct answer because it says when the door is when the count is even and time is greater than 15, then say the door is ajar. So on A, let's look at B. Now B is a little interesting because we're doing modulus math with 3. Okay, so maybe that could work, but if you keep thinking through it and test it out with a couple of examples, remember that 6 is even and 6 mod 3 will also give you 0. And so in that case, we would send the doors ajar message when it is actually closed. So B is also not it. So C does correctly check to see if a number is odd because we're dividing by 2 and we get a remainder of 1 and the time is greater than 15 minutes. So we accurately display door is ajar. D is also one of those odd ones where we just tried to do a modulus math by another option. And again, the same issue with 6 or other even numbers. You will get, this just doesn't work properly. So just think through that. You've got all the information that you need up here in the description. All right, next question. Okay, and our minute is up. Let's see how we did. All right, so we have a little bit of variety, and the correct answer is B. So let's take a look at why that is, okay? So I set up a table here because we have 8 bits, and just a kind of little vocab review, a bit is a binary digit, and it's only a 0 or a 1, and 8 bits is a byte, B-Y-T-E. So we know we have 8 bits, and so here's our table with the powers of 2. So any number to the power 0 is a 1, 2 to the first power is 2, 2 squared is 4, and notice each column just doubles the one before because we're dealing with 2s, all right? And then we said, what's the largest number? So it's not 11111, okay? Sometimes students get confused about that. That's the largest binary number, but notice it's asking us what's the largest decimal number. And then for our conversions, we're basically doing 1 times 128 plus 1 times 64. And we can just skip the 1 times part, okay? And if you add all these numbers up from this row, you get 255. Now, a shortcut way to always remember this is anytime you have all ones on the right, it's always 1 less than the value in the next column. So in this case, 128 doubled for 2 to the 8 is 256. So this is going to be 1 less than 256, which again is 255. It works just like our decimal system. When you get to 9, it's 1 less than the next column, which is our tens. When you get to 99, it's 1 less than the next column, which is our hundreds. So if that helps you make that, that parallel and that leap to binary, by all means, use it. Okay, next question. All right, that's about a minute. Let's see how we did here. All right, and the correct answer is C, which most of you got, so very good. This is a type of question you'll probably see several like. They like to do the missing code kind of thing here and what code could replace it. So you've got to know how to calculate the average. That is one of the common algorithms that you are responsible for knowing for the exam, and this is one way they kind of test that knowledge. All right, so, and you probably already know from calculating your own GPA or course average that, you know, you add them all and then divide by the number of elements that you added. Okay, so notice we don't have count here. We have no variable count over in our procedure. So while if we had count, that would work, we don't. So A is out. B is just trying to divide the sum by nums, and that's our whole list. So it tells you the list of numbers stored in a variable called nums. So we can't divide by a whole list, all right? But we can use that length. Remember that method? That's one of those that you're responsible for knowing how to use. And this is the perfect use for it. It tells us how many elements are in our list, and that's how many we would have added together for the sum. So we'll divide by that. Remember that length is also going to be listed on that exam reference sheet that you do get to take the exam. Okay, so if you remember, oh, how do I do this length, or how do I do any of those other methods, they are on that quick reference guide. All right, couple more. Here's the next question. All right, there's our minute mark. All right, and the correct answer is B. So let's take a look at this one. This confused my students as well when I gave them this one. So remember, with a procedure, it has to match the name exactly, spelling as well, okay? So if we come down here and we look at our options, the only two that are spelled exactly the same are B and C. So we've already eliminated two possibilities. Then we come back up when we look and we see our procedure does have a parameter. So that tells us that when we call this function or this procedure name, we have to pass it a value. So we just come down and we check out of our two options that spelled it correctly. B is the only one that gives a correct value. Now, my students were confused because they said, well, I don't know that there's a score in blue team, but what they have to remember is that it's a variable. It could be the blue team score, most likely, but it's just a variable holding a value. They thought just because 25 was a score, or what they could recognize as a score, that would be the one to use. So hopefully you guys will not make that same mistake. It's got to match the name and have an argument to pass. All right, next question. All right, and it's been a minute. Let's see how we did. Yay, okay, very good, everybody. So hopefully nobody guessed, but just to briefly review, this is one I would write in your booklet. And I wouldn't write out all the words like I did. I did that for your benefit. I just put G for grapes, O for oranges, and I wouldn't even include the quotation marks. But just write it out, follow each step, and then I put the index position down here at the bottom. And that just then makes it very easy to say, oh, what is that index position 3? And it would be bananas. So good job. All right, next question. All right, and there's our minute limit. Hey, all right, way to go. Good job, everyone. The correct answer is D. Just kind of look through it. You know, if you're going to display and update a digital scoreboard, that's going to be the last thing you'll do. So we've already eliminated 2 options by knowing that we have step 1 is the last thing. And then just make sure that you're getting the input for points 1 before you update score 1. And then you have to have the input for points 2 before you can update the score. Excellent. All right, next question.
Julie, we're at 5 o'clock, so we're doing well. Just let you know, we're like 2/3 of the way there.
Okay, thank you. All right, and there's our minute mark. And the correct answer is B. And good, most of you got B. Now, you got to look closely at this one. This one was a little bit tricky in the sense that if you look at our table, notice that value 2 doesn't change at all. So in our code over here, you can go ahead and eliminate any of the responses that are trying to change the value of, or change the value of value 2. So again, write this one down in your test booklet, okay? So if we start with the initial values for value 1 and value 3, because we don't need to worry about value 2, temp becomes a value 1, so it's at 22. Then value 3 gets updated with value 1's value, 22. But hey, you can already see we've already lost the value 42. We didn't save that anywhere. And then when value 1 gets updated with temp, it is also 22. So let's go on to option B, which we know works now, but temp gets updated with value 1, so it's 22. But then we update value 1 with value 3 first. So it gets the value of 42, and then value 3 gets updated with temp. So those two are properly swapped. So just watch for that. It's really easy to get a little confused in your head. My students, the ones who inevitably are trying to do it in their head, usually miss it. So don't do that to yourself, especially on the exam. With the added pressure of the time, just write it down. You'll save time in the long run. All right, next question. All right, there's our limit. And let's see how we did. And yes, indeed, the correct answer is C. So this is testing whether you really understood lossless and lossy compression techniques. And while it seems hard to believe that a 5-minute video could ever be smaller than a 5-second video, some of those lossy data compression techniques could definitely do it. Usually the quality isn't great because I've had to try that before, but it can be done. All right, couple more. Almost done with these. And there's our limit. Let's see how we did. Oh, y'all made me very happy. Okay, yes. Even though you may be tempted to give them all this information without thinking, because you guys are a lot more used to sharing information to get access to stuff than I am, okay, as a digital immigrant. But yeah, any site that needs to collect all of that from you for you to be able to play their game is just going to do something with it that they have no business doing with it, whether they sell it or something else, okay? All right, last of these multiple choice practice questions, I think. All right, and our time is up for this one, and let's see how we did. All right, not too bad. The correct answer is C. This concept was new in the curriculum updates last year. So if you're using an older review book, ours is updated with this current information. So we're looking at parallel, distributed versus sequential processing, okay? And what they're really looking for here is to see if you understand the concept of speed up. And just as a little reminder, the calculation is the sequential time divided by the parallel time. You're not likely to have to calculate it, but do be aware of the formula if you do, okay? But it does result from the difference in time each data center takes, so you can measure the efficiency of each. All right, so just kind of give me any questions or give me an idea how you're feeling about your understanding, your information, how well you did with these. So hopefully it'll help you realize what you might need to focus on a little bit as you start doing that last prepare and review for the exam. The next thing, I just want to touch on this. This also changed last year, okay? So this is, we used to have to do a second project in addition to our create, but now they've replaced this with what they call the explore curricular requirement. And your teacher will have or will be going over some practice questions that we're required to do. So what these are is they give you a paragraph with information in it. And all the questions I've seen have always been replaced or always included like a chart, a graph, some other kind of visual representation of information. And then they're going to have 5 questions related to that information. But these are related to things like privacy versus security or storage requirements or unintended harmful or beneficial effects, okay? So let's have a couple of sample questions and a scenario for you to look at here. So here is a practice question. I'll let you read that. Okay, and then you see the flow chart here is saying, check the time of day. If it's a weekday and rush hour, then initialize the ramps, ramp lights, okay? If it's not either of those, then check the camera data to see if the number of vehicles is greater than some threshold. And if it is, turn on the ramp lights. Otherwise, nope, just go back and check again and keep going. All right, so here's a sample question. And again, I will give you a minute to answer these because they are all together, by the way, on the exam. All 5 are one right after the other. All right, and the correct answer for this one is A. So it's asking which of the following pieces of data can't be captured at the ramp entrance, and it's the number of cars on the highway. So you'll have the date, you'll have the location of the ramp and meter, and you'll have the data that shows the number of cars that pass through the ramp an hour, but not the number of cars on the on the highway. All right, next question. All right, and for this one, the correct answer is A. Which concern is most realistic? Now, some of these are still concerns, but it's, there is a little bit of nuance there. But with the camera taking photos of cars on the entrance ramp, along with the day, the time, the location, all of that, your privacy, the privacy of your information is at risk. So the combination of all that data could be used to identify the owner of the car, even though it may not be able to determine who was actually driving it at that time. So your whereabouts could be tracked and you could be identified through it if the data is not adequately protected. So it could, could be a security concern if Department of Motor Vehicle employees could update the data, but it's very likely that they can view the data as part of their job. The storage concern, yes, that could certainly be a issue, but there are server farms out there that are more than willing to collect and aggregate data for anybody who's willing to pay. And then your personal protection, I just kind of made that up. That's not one of the things. It's privacy concern, storage concern. All right, question 3 related to this. All right, and this one, the correct answer is B. So what data could you use? So the typical traffic patterns will provide you with reasonable data to initialize your variables, initialize the timing for the ramp lights. The camera for A and the sensor data in D, they provide data, but it doesn't tell you exactly what kind. And then the number of red and green cycles per hour is going to vary based on the hour, based on the amount of traffic. So that really won't be that useful. So the best answer here is B. All right, question
Julie?
4 related to this. Yes.
Julie, would you mind if I just jumped in? We've got about 12 or 13 minutes remaining. I don't know if you think you might have enough time to get through everything. That should be, I just wanted to bring that to your attention in case you wanted to move quickly through certain sections. Is there another section to come after this before we do the cross-platform?
Very short, very short. So we're almost done. I think we'll make it.
All right, good.
Okay.
Good job.
All right, and on this one, B is the correct answer. All of the options list a possible benefit, okay, but notice they are asking for the least likely. Watch for that kind of stuff in these questions. Which one is not, or which one is least likely, which one is most likely? So again, I'm definitely one of those who changes my route to try to get to a less congested entrance ramp. Definitely fewer accidents is more likely. Decrease fuel consumption, I would give serious consideration to, again, but with the air quality, you can't necessarily, the cars are still on the highway and you can't prove necessarily that any improvement in air quality would be a result of the ramp lights. Last practice question. And the correct answer here is D. Okay, so the data, you got to remember, and they always seem to work this in there somewhere. Sensors and cameras by themselves are not data. They are devices that provide data. So you can just immediately, if they just have that without any specific data related to them, those are not the correct answers. And since we're looking for the amount of traffic on the ramp, we got to know on the side, we got to know if the side roads are backed up. So that's the piece of data that we need to know, some type of sensor or camera data related to that to know like, oh, we're backing up side streets. We have too many, too slow of a cycle going, too many cars on here. So let's just turn off the signal for now. And with that said, any questions, please let us know, and let us know how you're feeling about these Explore questions.
Julie, there was one question from Karen.
Okay.
She noticed that you did not deal, the questions you gave didn't deal directly with the internet and how it works. She's wondering if that's a topic that needs more of a review.
Oh, it absolutely does. I kind of had to pick through the questions, and that's really going to tie in here nicely. Let me come right over here, because the very next slide I have shows the percentage of exam questions based on the big idea. And if you look at the computer systems and networks, it's like the next to last category for the percentage of questions that'll be there. So I focus most of these on algorithms and programming, because you need that perhaps to finish up your Create project, as well as most of the questions are going to come from there. Teachers, if you're interested, or students, if you're reviewing, I usually save the impact of computing for last, even though there's a pretty good percentage there, simply because historically my students have found those to be more intuitive. So they didn't necessarily have to review as much. They could reason it out or logically induce it or deduce it. So I always go for the algorithms and programming, then the data, then creative development usually gets inserted in with those, and then the computing systems and network. So definitely review that. There are definitely questions on there, but it is a lower percentage than some of the others. So good question, Karen. So just to review the scoring, all right, we already talked about 30% is your create task, 70% is your multiple choice, and there are 70 questions. So each question is 1% of your overall score, right? There is no penalty for wrong answers. Please answer everything, even if it's a wild guess, okay? The exam is 2 hours long, all right? So it's only the multiple choice section, which is why it is shorter. So you roughly have 1 minute and 42 seconds per question. Some will go a lot faster, some will have a little bit more to read, so you'll need to kind of wade through that a little bit more. Don't count on having a break. Okay, you're going to go straight through with the 2 hours. Go ahead, and even if you're not sure about an answer, go ahead and at least put your best guess on the scoring sheet. So you don't get off by one, by missing a column, by missing and answering one. And if you don't have time to go back and check them, you'll still have an answer there. You can usually deduce or eliminate at least one option, increasing your odds. I would recommend taking the diagnostic exam now or fairly soon, and that will show you areas to focus on. The questions at the very end are divided by category, so you can say, oh, I missed more in the category of the internet. I should review that a little bit more. Then take the practice exam 1 roughly 2 weeks before the exam and review as needed. And then just for more practice, look at practice exam 2 about a week before the exam. But the night before, pack your pencils, identification if you need it, get a good night's sleep. You're really going to remember more than you know. Sometimes the questions will trigger things for you. Just get a good night's sleep. It's the best thing for you. Eat a good meal beforehand, a healthy meal. You can have a watch, but not one that can connect to the internet, just like with all the other AP exams. No calculators, no scratch paper, no cell phone. Write your work in the test book, trace through your code, eliminate answers, and again, answer everything. And remember, you're going to have that wonderful exam reference guide as needed with the multiple choice questions. 28 days until the Create Performance task is due, and 35 days from today until the actual exam. You guys are going to be ready. And with that said, I will pass it over to Bob.
Thanks, Julie. Could you hit the next slide, please? There we go. I would ask everybody to take a quick picture of this. We're going to offer you in the next couple of minutes just to show you what we have to offer, but there is a digital course waiting for you. So if you take down this URL and access code, I'll give you a few seconds to take a picture or jot it down on paper. And actually, maybe Anya, if anyone needs it later, could you stop sharing, Julie, so I can start sharing and just walk them through in next 4 or 5 minutes?
Absolutely. There you go.
Okay. So this is your cross-platform prep course. We call it bench prep. That's an internal term. Once you get into the URL that we just showed you, you'll have to enter a voucher. It's really simple, the voucher code. And then when you get in, just your name and a quick email address, and you're in and studying within a minute. What you'll find when you first get here, like Julie, is your dashboard. So the first thing the program's going to ask you is for what your test date is. For you guys in computer science principles, it is May 9th. So as Julie said, there's 35 days. Every day you come into this program, it's going to show you the exact number of days you have left until test day. It's a self-guided study program. There's a lot of information. I haven't been through this yet today, so there's no updates here for me. But I really would urge each of you to get in here and see what you can find, because there's a lot of really robust review that's going to help you between now and test day. Real quickly, the study plan is everything in the book. Each chapter of the book broken down into key ideas. As you go through, you can rate your confidence in each subject. So this is a creative development overview. I know that. Creativity and computer science, no problem. Computing innovations, I want to rate myself as low, because I know that the next time I come back, I will want to revisit that place. Real quickly, there are games in here that you can use. They're basically all based on flashcards, nothing too crazy, but if for gamification, if you want to study on the bus. And before I move on, that's an important point I want to make. If you start, the program will follow you. So if you start studying at home on your Chromebook or your PC, and you get up to question 19, you have to leave and grab the bus. You get on the bus and you play it on, you punch it up on your phone. It'll start at question 19 and follow you. It's a really good interactive program that way. There's a discussion piece. I noticed in this one, there are quite a few discussions that are happening back and forth. That's pretty uncommon, so it's good. Is the AP Computer Science Principal exam hard? What's the answer to that, Julie?
It is not hard.
It is not. All right, good answer. So here's the lesson, I guess, the breakdowns. This is where I was before when I graded myself as I went through. Every time I come back to the lessons tab, I will go through, and wherever I rated myself as high, I know I don't need to go back. If I rated myself as low or medium, that's a good way of keeping track of things that I know I want to come back and revisit. There are great flashcards in here. For example, abstraction, one click gives you the definition. Did you get it right? Again, it's very self-guided. So if you get it right, yes, you'll never see it again. Algorithm, I was kind of not really that confident. Rate myself a no. And again, next time you come back, whether on your phone or on your PC or any device, it's going to follow you and start. And the ones that you graded yourself as not knowing the first time through, they will appear again. So it's an optimal review for the test. The practice is all the practice questions we have in here based on the section. So for example, you want to go into algorithms and programming, practice that category is 36 questions. You can either review with the answers that come up or turn that off if you want to do them all and check your answers at the end. So for example, I'm not going to know the answer to this. I'm just going to guess that it's B. And I got that one wrong. So it's a real good way of getting through all the questions. And then finally, what Julie was just mentioning toward the very end there is the full length practice test. You want to do test 1 now, test 2, run it a week or 2 before the exam. I think you said 2 weeks, right, Julie? And these are going to mimic the real test day. You get in here, you start the test. It's the full 2 hours. It's everything you need to really prepare yourself for sitting for 2 hours and answering those questions that you're going to see on test day. For this, you will not be able to toggle back and forth to see the answers on the test because it's mimicking the real thing. You'll only be able to answer them all and then get your results at the very end. And that's it. We're almost out of time. I would urge you guys, that was a very, very short introduction to the online course, but there is a lot of really good stuff in here. Please feel free to share that for the educators on the line. You've got colleagues or other teachers out there that you know might find this valuable. Please feel free to share it. Students, share it with your buddies. There's a lot of good stuff in here for you to review for the test. And that's it from me. Do we want to come back? Did you have any closing thoughts, Julie, before we adjourn?
That's it. Just relax. You guys have got this. You've been preparing. And again, you can reason through a lot of the questions and at least eliminate some of the answers. So you've got it. Good luck.
Okay, good luck, everybody. And Julie, thank you so much. Really terrific job today. That was a lot of excellent stuff that you shared. I'm sure everybody appreciated it. We really appreciate your time. And thank you all for participating and for coming today. So at that, we will call it. Thank you, Julie. Thank you, everybody. Take care.